Assalamualaikum warahmatullahi wabarakatuh. Hi everybody. Let me introduce myself to you. My name AndrianABAS. You can call me Abbas. I am a refinery instrumentation engineering of PEM Akamigas. So today I would like to perform my resume journal in the topic of artificial intelligence, that subtopic neural network. So here is our outline today. First, we will discuss about the introduction, and then the second is data architecture, next to the methodology, and then stability, analyze, simulation and validation, and in the end, we will have a conclusion. So let me start to our first topic about introduction. So here, I am using an adaptive PID neural network for compact nonlinear system control that you can find on www.elsevier.com, or you can find in a book of Neurocomputing, volume 135, that published in 2014, page 79 till 85. So this kind of paper is read by Jun Kang, Wen Jun Meng, Ajit Abraham, and Hongbu Liu. They are a research for a Chinese. So here, first is about introduction. In the industrial field, the control system usually has a great non-linearity. We can find it in example, spacecraft system, and then vehicle system, robot system, power system, chemical reaction system, and etc. It is hard to get a precise control performance even by the intelligent control methods, including adaptive control, fuzzy control, neural network, and decoupling control, and many more. So many mixed control methods are present, such as PID neural network. Due to the characteristics of self-learning, self-organizing, and self-adaptation, PID neural network will automatically identify the parameters of control system and adjust according to the system change. So here we have two main problems. The first is about the great non-linearity, and the second is how to mix a control that giving a good performance for solve the great non-linearity problem. And here the authors giving you a solution through a PID neural network. So let me see how the authors will be give the formula for the better performance of control system. Here is the purpose of this paper. First, the authors want to find the adaptive control system for a complex system. It means present a controller model based on the adaptive PID neural networks that giving a good performance for a complex nonlinear system. And then the second, when we have the model base of adaptive PID neural network, we want to prevent the weights of neural network falling into local optima. Why? Because it's very dangerous. So here the authors want to giving a PSO algorithm is adopted to select the initial weight. The parameters of PID neural network are self-regulating without intervention. So it means the improve of the gradient descent will be very useful to optimize the weight of the network. Here is the data architecture that you can see in the screen. The control system adopts a closed-loop control, and it mainly consists of two parts. First is the controller, and the second is the control system. So on the right side, you can see I have two figures. Figure 1 is the structure of the control system, and then the second is a figure of structure PID neural network. So this figure basically similar. If you see on the red box, those are the input of the system. We have X for the set value and Y for the feedback value of the output. Then next, in the structure, there are a PID neural network inside a blue box. And below, there are three circles. These three circles means that this PID neural network mainly have three hidden layers. So those are consist of proportional controller, then integral controller, and derivative controller. And then the last, on the inside of pink box, you can see here is the output of the controller that will be come into the control system. So here is the methodology. First is about the control system structure. So the authors want to giving you an algorithm that will be used to find the control system structure. For the algorithm that used in this case, you can see on the text that I have giving a yellow color. So here first is about the input the object value and then initialize the wake of PID neural network and then use this PID neural network to control the controlled system. The feedback of the output of the control system will be used to adjust the parameter of PID neural network. So it will be improve the gradient descent method. And the last, if the control error is small enough, the algorithm is terminated. But if not, it will be returned to the step 3. Then after we have done for case of algorithm 1, then we have the second is to find the PID neural network controller. So here, as I have said before, that in this kind of PID neural network controller, we have three hidden layers that consist of proportional, integral, and derivative. And here is the formula to find the output value of those hidden layers. And then third, it's about the parameter initiation. That is mean the author used the PSO adapted for giving a combine of algorithm 2. The algorithm 2 is about the particle swarm optimization algorithm or PSO. Here, first is always start with initialize a group of individuals by a random algorithm. Then the second, it will be calculate the fitness of each individual. And then the third, for each individual will be compared to the another individual to find which one is have the better fitness value. And then for each individual that have been compared the fitness with the other fitness global basis story position, when the former is superior to the latter, then GBHP will be replaced with the subscript and the fitness of the current individual. And then it will be update the position and the velocity of the particle. And the last, we will check and the condition. If it's giving a good performance of if satisfied, the algorithm is over. Otherwise, key here is equal key plus 1 that will be returned to the step 2. The end of the condition is that a good enough fitness or the maximal desired evolution population indeed reaches. And the next is about the adaptive parameter adjustment. Here in our neural network, The parameters are computed in each sampling period. The weights are automatically adjusted according to the error of closed-loop system, and the controller will be help us to implement a nonlinear and adaptive real-time online control for the control system. So it will be improve the performance of our control system. The next we will be discuss about the stability analysis using Lyapunov methods, and in the end we will use a simulation and validation for checking our formula that we have presented before. So here is the stability analysis. In this paper, the authors use kind of Lyapunov method. So what is Lyapunov method? Here is Lyapunov method. So you can see there are many combination of formula that use in Lyapunov method. But we can discuss about this formula later. So I will be giving you the outline of this formula. So the main idea of Lyapunov method is this function where phi of k is equal a half of sigma q start from 1 till n from u 2 degree times k. So what is the kind of parameter that used to determine that the system are stable or not? So in this Lyapunov method, the closed loop system is stable if the delta phi of k is less than 0 in any sampling period. So next, we have some parameter simulation. Here we have some parameter simulation for checking and validation of our formula. So first, we will give the initial value of the control system as specified as 0. And then the second, the object value of the control system are specified as 7, 4, and 8. And then the learning rates is determined in 0.006 seconds. And then the time interval is specified as 0.0001 second. So here in this paper there are 3 kind of methods that authors presents. First is the control of traditional PID neural network, and then the second is a PID neural network that combined with particle swarm optimization, and then the third is the formula that have author combined that's called the adaptive PID neural network. So let me see what the author have presents in this paper. So here, from the 3 methods that have been the authors presents, we can see that for the figure 3, 4, and 5 is the control traditional PID neural network. And then for figure 6, 7, and 8 is a PID neural network combined with PSO optimization. And for the last is the adaptive of PID neural network. So here in the graph you can see that for the first method it have a good performance that have a settling time for about 0.1 second, and the control error of varies with the time is also decreased significantly in less than 0.1 second. And then for the second method, You can see that in figure 6, there are a ripple in the graphic. And when we trying to find another input, here is the error increase. But actually it have a better performance in rest time, that the value is for about less than, or I estimate it's for about 1.0 0.01 second. So it's very fast. And then here is the best graphs that the authors presents to us for the third method, the adaptive PID neural network. Here we can see that the rest time is less than 0.001 second. So I can say that it's 10 times faster compared to the second method. And actually it has a good performance. He can decrease the error value less than 0.05 seconds. So here are the graphs that the authors want to present to us. And then from the all of the graph that we find using some methods, the three methods, we compare the error value. Here there are the mean average of the total error. First method, second method, and the third method. So the values can quickly approximate the object output values by our proposed method. It means that the control error is falling faster before 0.02 seconds. Then tends to 0 is gradually. The control laws are also quickly changed to the constant within a short time. Therefore, the adaptive PID neural network controller has a fast convergence speed, high accuracy, and reliable stability for the complex nonlinear system. So here we can see that our third method have the smallest average of error compared to the second and first method. So here is our conclusion that we get from this paper. First, this paper giving us an adaptive PID neural network controller that was presented. And then second, in this paper, the authors using the PSO algorithm was adopted to select the initial weight in its training for improving the convergence speed and prevents the weights getting trapped into local optima. And we know that in each sampling period, an improved gradient descent method was used to update the weights in this network. And we know that the stability of our controller is analyzed according to the Lyapunov method. And then, from the empirical result that we have been illustrated, or you can see on the table 1 before, giving us information that the adaptive PID neural network is significantly better than the other considered method. It means the method 1 and the second method. So I think that's all that I can deliver to you. Thank you very much for your nice attention. I hope this presentation can give you a knowledge and give inspiration to you to write another paper. Please forgive me if you found a lot of mistakes in my presentation. And if you have any question, you can contact me on my email on AndrianABAS using s@gmail.com. So the last for me, thank you and wassalamualaikum warahmatullahi wabarakatuh.